Okay, so this lesson finally is how to graph transformations of secant, cosecant. Hopefully in the previous videos you learned why secant and cosecant look like they do and what vertical asymptotes are, where you get them, why you get them. If you don't, go back and watch those videos. So we're going to graph cosecant on this first example and then secant on the second example. And the most important thing to understand about either of them is you have to know that cosecant and sine are related to each other. They're reciprocals, yeah. So before I even start, I'm going to replace that with sine because I know how to graph sine. And then if you're trying to graph secant, you want to first graph cosine. And before the break, you guys were pretty stinking good at graphing these, except when the phase displacement was on the left of the y-axis. Then that was a little bit troublesome for you guys. I remember that. But these two examples, the phase displacements are pretty easy. So 5 is the sinusoidal axis. Again, keep in mind I'm going to first graph sine. 1, 2, 3, 4, 5. And amplitude is 2. So 6 and 7. 1, 2, 3. Voila. So there's your road. Top of the road. Bottom of the road, middle of the road, aka sinusoidal axis. Okay, and frequency is 6, and if you recall, to find the period, you take 360 degrees and divide it by the frequency. So 360 divided by 6 equals 60 degrees is the period, and the phase displacement is positive 40, and basically that's where you're going to start a cycle. 40 degrees, the period is 60 degrees, so 40 plus 60 is 100. And then it's a little bit off proportionally, by the way. Like there's no way that could be 40 and that's 100, but good enough for right now. What else? Oh, so a cycle. We're going to graph one cycle. A cycle has 4 parts, so you're going to split this into 4 parts. 1, 2, 2, and then tell us what these numbers are. 40 plus 100 is 140. Cut that in half, you get 70 right there. 70 plus 40 is 110. Cut that in half, you get 55. So obviously the scaling is 15 degree increments, so it's going up by 15, going up by 15, going up by 15, 85, voila. Then you're going to graph one full cycle of sine. Sine starts in the middle, and it goes to the top, back to the middle, back to the bottom, and then back to the middle. So there's one full cycle of sine, and then as I alluded to in the previous video, vertical asymptotes will occur when the parent function hits the middle of the road. So right there, it hits the middle of the road right there, so you get another vertical asymptote, and right there. Okay, and mathematically, why do you get vertical asymptotes there is because if you plug in the 40 here, you get 40 minus 40, which is 0. 6 times 0, which is 0. Sine of 0 is undefined. No, it's not. Oh, cosecant of 0 is undefined. Sine is defined. Sine of 0 is 0. Cosecant of 0 is undefined. So that's why you get a vertical asymptote. Whew. Okay. And then all of that you do just so that you can graph sine or cosecant. Here's what we need you to do. This is the point of inflections right there, and that's part 1, part 2, part 3, part 4. So when you're graphing sine or secant or cosecant, the part I just did in blue, hopefully you're not colorblind, that's what we really need to see. All of this is, I mean, obviously you can't graph cosecant until you first do all that stuff for sine. Alright, next example. Cosine, secant. Process is exactly the same. Before you can graph secant, you have to first graph cosine. That's the difference. Okay, sinusoidal axis is at 2, 1, 2. Amplitude is 5, so go up 5 spaces, 3, 4, 5, 6, 7. And if you went down 5 spaces, 1, 2, 3, 4, 5, you end up at -3. Recap from where these numbers occur. If you take 2 plus 5, you get 7. If you go 2 minus 5, you get -3. So that's the easy way to do it. And here's the top of the road is right here. Middle of the road right there. I would suggest not doing it in pen, by the way. We're doing it in pencil because, again, it's that blue part that is the answer to the question. And -3 is the bottom of the road. By the way, top of the road and bottom of the road are technically horizontal asymptotes. Frequency is 3, so to find period, you go 360 divided by the frequency. 120 degrees is the period. We are starting at positive 25 for the phase displacement. So I'm going to put up positive 25 right there. And then 120 degrees later, you end up at 145. Again, this number plus this number always tells you the end of the cycle. And then if you cut that in half, that plus that is 170. Half of 170 is 85. Let me double check. 170 divided by 2. 85. And then cut this in half. 85 plus 25 is 110. Wait a second. Yeah, 110. Cut 110 in half. You get 55. That does not seem right, but it is. Or another way to do it, by the way, is you just divide that by 4. 120 divided by 4 is 30, so the scaling should be 30. 25 plus 30 is 55. 85 plus 30 is 85. 85 plus 30 is... Why is this not happening? 115. Wow. Okay, and then you're going to graph one cycle of cosine. Cosine starts at the top. Then it goes to the middle. And then bottom. Back to the middle. And ends at the top. And you get piece number 1, piece number 2, piece number 3, piece number 4. The vertical asymptotes occur when the parent function crosses the middle of the road right there. Dun, 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 and right there. And then right here, point of inflection, and right there, and right there. And then here's part 1. Be careful not to touch the asymptote. Part 2. Part 3. And part 4. And like I said, if you don't like the way that looks, you could add another vertical asymptote over here at -5 and make it go like that. But then you'd have more than one cycle, and if the directions say graph exactly one cycle, then you have to have exactly 4 parts. So keep that in mind. If you don't like the way this looks and you want to not have this piece over here, the next vertical asymptote would occur 30 degrees to the left, which would be at -5, like that. I'm going to get my picture again. Voila. So this, by the way, is perfectly acceptable, but I find that a lot of kids just don't like that, the way it looks. And if that's the case, then go ahead and do that. There. Now it looks exactly like sine or cosecant. And on the assignment, we're going to give you 4 of these to practice and 4 of those to practice. So 8 problems total on assignment 1 for this week. There will be 3 total assignments. Contact us if you have trouble.